Good morning, students. Today we are studying about square and square roots. This is a new chapter. In the last class we did about the understanding quadrilaterals. Now here we have a square and a square roots. Okay, what are the square and square roots? Now in this chapter we are starting with the introduction of square numbers. What exactly and how it came. Now in the previous chapter we have learned about this. What is this? This is called as the square. What are the properties of this? We have a right angle for all four. It can be named as A, B, C, D. In this, all sides are equal. Okay, the thing which we did not learn is how do we find the area of this one? Area is nothing but this part. The boundaries which is enclosed, that is called as the area. How do we find this? Now the area of the square is nothing but, if I tell this is side A, side A, side A and side A. So the area of the square is nothing but side into side. It is nothing but A into A, which is A square. This is the area of the square. That means inside this boundary, this is a space and it is always written in square units. When I say square unit, it can be square centimeter, square meter, square kilometer. Anything is fine. Now here, instead of A, if I have here 1 centimeter, so this will become 1 square. If I have 2 centimeter, it will become 2 square, which is nothing but 2 into 2. So this one we can write it as 2 square. So in general, what is square? It is nothing but an integer. When you multiply any integer with its same, you will get the same integer square. That means you are multiplying with the same integer. If I take minus 1 into minus 1, it will become minus 1 square. If I take 4 into 4, it will become 4 square. If I take 2 into 2, it will become 2 square. Okay? These are the squares. Now, this is how we represented square numbers. Now in number system, how do we find the square numbers? Square numbers are nothing but, if you start with the number 1, 2, 3, 4, 5, 6, 7. If you multiply with the same number, you get the square number. 2 square, which is 4, into 3 is equal to 3 square, which is 9, into 4 is equal to 4 square, 16, into 5 is equal to 5 square, 25, into 6, which is 6 square, 36. Now if you see all these numbers, these are called as square numbers. And why do we call these as square numbers? Because we are getting this number by multiplying the same 2 digits. Same 2 digits. Same 2 integers. Same 2 integers. When you multiply the same 2 integers, you are getting the square numbers. Now what are the numbers between all these squares? If I write 1, this is the first square, 4, 9, 16, 25, 36. There are a few numbers in between, right? In this case 2 and 3. Here 5, 6, 7, 8. Here 10, 11, 12, 13, 14, 15. All these are the numbers which are not a square. These are the square numbers. Okay? These are the square numbers. Now, if you see a pattern of the square numbers, if you see a pattern, this is the first square number, second square number, third, fourth, fifth. Now, inside between 1 and 4, how many numbers we have? 2, right? Correct? 2 numbers we have. 2 and 3. Now, between these two, 5, 6, 7, 8. 4 numbers we have. Between these two, 10, 11, 12, 13, 14, 15. That is 6 numbers we have. Do we have any kind of a pattern? When I say pattern, if I have to find the non-square numbers between two consecutive square number. That means if I have to find the numbers, how many numbers we have between these two squares. If you see it here, there is a pattern here. Okay, the pattern is 2 multiplied by, how many numbers we have here? 2 numbers, right? Which is, so we are finding between these two. Now here if I ask, 3 square and 4 square. How many consecutive numbers, how many non-perfect squares we have between these two? I can directly write 2n, where n is equal to the first number. N is equal to first number. In this 2, the first number is this is the second number. So I can write 2 multiply, n is the first number which is 3. 6. I have 6 non-perfect square. Can we check this? 3 square is 9, right? 16 is 4 square. How many numbers we have? 10, 11, 12, 13, 14, 15. See, 6 numbers we have. Similarly, I have to find 10 square, 11 square. I want to find the numbers between 10 square and 11 square, which are non-perfect square. I can again use 2n. It is nothing but 2 into 10. N is the first term. Now what is 2 into 10 is 20. Now what is the 10 square? 100, right? And what is 11 square? 11 square is 11 into 11, which is 121. So numbers between these are 100. 1, 2, 101, 102, 103, 104, up to 120, which is 20 numbers we have. Okay? Similarly, you can try the total number of non-perfect square between 30 square and 40 square. What do we do? 2 into n, which is nothing but 2 into 30, which is 60 numbers are there. If you want, you can check it out. 30 square is 900. 40 square is, how much is 40 square? 40 into 40, which is, if you check this, you should get those many numbers. Now we started with the introduction of square roots. Now the next one is the properties of square roots. Now the properties, when I say properties, it is nothing but how can you tell a given number is a square number or not. If you know the pattern again, whenever you have the square numbers, this is the first one, 4, 9, 16, 25, 36, 49, 64, 81, 100. Okay? If you see all the unit digits, what are the unit digits? We have 1, we have 4, we have 5, we have 6, we have 9, and we have 0. These are the unit digit of a perfect square. So when you are telling, if you are telling any square number, make sure that you have 0, 1, 4, 5, 6, 9 in the end. If you do not have, then it is not a perfect square. If I tell randomly 6, 5, 2, what is the unit digit? 2, right? Do we add that to the list? That means it is not a perfect square. You can, without any kind of a calculation, you can directly tell. See this number. Whenever you are checking for a perfect square, ensure any one of those numbers are there. If you have this, then it is a perfect square. If you do not have, then it is not a perfect square. This is the first property. The second property is, if you have 2, 3, 5, 7, in any number given, example 727, look at the unit digit. This is the unit digit. In the unit digit, if you have any of these numbers, it is a non-perfect square. The moment when you see in the unit digit number 7, you can directly tell it is a non-perfect square. Let us see next property. And then, when you are multiplying, whenever you are multiplying or whenever you are finding the squares of a number ending with a 0, for example, 20 into 20, which is nothing but 20 square. Okay? The number of zeros will be 2 times of the number. Example, 20 square. How many zeros we have here? 1 0. 2 into 1 is 2. That means 20 square will have 2 zeros. 20 square is nothing but 400. See here, 2 zeros. Similarly, if you have a number 1000 square, how many digits we have here? 1, 2, 3, 4. That means the square of this number will have 2 into 4, which is 8. 1, 2, 3, 4, 5, 6, 7, 8. This is the square of this. So whenever you see the number of 0, just multiply with the 2. That will be the zeros in the square of that particular number. Okay, there are a few activities. The square of which of the following numbers would be an odd number or an even number and why? That means you have an odd number. Okay, you have an odd number. If you have to find the square of an odd number, okay, remember this, square of an odd number will always be an odd number. square of an odd number will always be an odd number. See here? All these are odd numbers. When you are finding the square of an odd number, it is always end up with an odd number. 23 square, which is nothing but 529. Okay, all these are odd numbers. Similarly, square of an even number will be even number. 22 square, 484. 8 square, 64. So, what is this property? When you are squaring any odd number, it will always be an odd number. When you are squaring any even number, it will always be an even number. The next part is, what will be the number of zeros in the square of the following numbers? They are asking to find 400. How many zeros we have here? 2 zeros, right? So in the square of this number, you will have 2 into 2, which is 4 zeros. Okay? Now the next part of the property is, you have a number 295, okay, or you have a number 3876. You do a square. The question they are asking not to find the square. They are asking what is the unit digit of this particular square. What is the unit digit? That means when you do a squaring of this number, you will get an answer here, right? In this answer, what is the unit digit? Okay? To find this, just take the last number and square it. What is the last number here? 5. 5 into 5 is 25. So this will be the unit digit. Similarly here, the last number is 6. 6 into 6, which is 36. So this will be the unit digit. So when they are asking for the unit digit, just take the last number, square it. In that square, whatever the answer you get, the unit digit will be the end of the complete number. This is about the introduction, the properties, square numbers, the numbers between the perfect squares. And in the next class, we will talk something interesting facts, interesting figures about the square numbers.